Let's try a couple of example problems now using the exponential function. The first one I want to talk about is the compound interest is a compound interest formula problem. I've given the compound interest formula here. It's A equals P times 1 plus R over N to the NT. And I've listed what everything is at the bottom. A is the final amount at the end of time T. P is the principal. That's the amount you either loaned, borrowed, or invested. R is the annual interest rate. For a rate to make sense, it has to be attached to a time period. So R is the annual rate. It's the rate you'd get over a whole year. And N is the number of times you would compound per year. T is the number of years in this formula. As for how many compoundings, I've given the words down here that associate with the compounding. So annual compounding means once per year. Semi-annual means twice per year. Quarterly means 4 times per year or once every 3 months. And of course monthly would be 12 times per year. So these numbers here, 1, 2, 4, and 12, that's what you're going to use for N in the formula. Over to the side here, I've done a different formula called continuous compounding. Now, continuous compounding means every little billionth and trillionth of a millisecond you compound. And that would seem like so much compounding that you'd make infinite money, but as we'll see in our example, it really doesn't make any difference. The important thing is to get compounding, and then you want to go for as much interest as you can. So let's go ahead and go into the first problem. The first problem says if $15,000, so there's my principal, that's what's invested. If $15,000 is invested for 20 years at an annual rate of 6.5%, what will the final amount be if compounding is A, annual? Well, if A is annual, that tells us that N, the number of compounding per year, is going to be 1. So we just plug into the formula. We're looking for final amount, so we don't plug in for A. That's what we're trying to find. But the principal, the amount invested, is $15,000. 1 plus, now, here I would put R over N. But since N is 1, R over N is just R, so I'm just going to put the interest rate. Now to change that percent to a decimal, when you change percents to decimals, you move the decimal 2 places. So right now it's at 6.5, so moving it 2 places would be 0.065. So I'm going to say 0.065 to the, and this would be N times T. T is 20, but again N is just times 1, so that's just to the 20. Now you could put it in your calculator like that, or you could take the 1 plus 0.065 and just change it to 1.065, because that's what it is, to the 20. And if you enter that into a calculator, it would look like this. If it's a graphing calculator, 15,000, open, 1.065, and then there's a little key that's to the power, and you'd put 20. And when you punch that up in your calculator, you get 52,854.68. Let's go on to the second one. In the second problem, all the facts remain the same except that compounding is now monthly, so N is now 12. But other than that, we plug in everything the same. P is still 15,000. But now when we come to 1 plus R over N, we put 0.065 over 12. Now a lot of people at this point like to put that in their calculator and round that off. You got to be careful about that. If that doesn't come out even, you're better off leaving that 0.065 over 12, because round off error can kill you in this kind of a problem. And then for our exponent, it's NT, so that's 12 times 20. Now there are some things you need to know about the use of calculators which do order of operations for you, like graphing calculators. There are certain things you must bracket. If you have a fraction in a problem, you must bracket that fraction. So I'm going to bracket this fraction. If you have more than one number in an exponent, you must bracket that exponent. Folks, if you don't, your answer is going to be wrong. So this is what we really want to put in our calculator, and when you put it in the calculator, it's going to look like this. 15,000 times 1 plus open, 0.065 over 12 close. Close again to the power, open, 12 times 20, close. And you need all of those brackets to get the right answer. If you put that in your calculator and press enter, you get 54,846.70. Make sure this is written out on your paper before you put it in your calculator. That's very important. If you do the round off stuff and you come up with the wrong answer, you're going to lose points. So put it in like this. It's easy to do. Just bracket your fraction, bracket your exponent. And finally, continuous compounding is kind of easy. Here we do the formula A equals P, still 15,000. This time you have to hit E to the RT, and your R is 0.065, and your T is 20. So again, you have an exponent with more than one number in it, so that's going to have to go in a bracket. Now to get E on your calculator, you're going to have to press second ln, and that's going to produce the symbol e to the power. So here's how it's going to look in your calculator, 15,000. Then you hit second ln, that gives you e to the power. Then because there's more than one number, you bracket your exponent. And the number you come up with is 55,039.45. And notice that's very little different than the previous answer. So the most important thing is get your compounding. After that, go for a high interest rate. Okay, number 2 says the 1986 explosion at Chernobyl in Russia sent 1,000 kilograms of radioactive cesium-137 into the atmosphere. The function f of x equals 1,000 times 0.5 to the x over 30 power gives the amount of cesium-137 remaining in Chernobyl X years after 1986. If even 100 kilograms remain, the area is unsafe for humans. Will it be safe in 80 years, 2066? Boy, what a bunch of words. Don't let words throw you, folks. They have given you the formula for the cesium in the air. And they've told you what x is going to be. It's going to be 80 because they say where's that? Yeah. Will it be safe 80 years later in 2066? He's given you everything. The formula's set up for you. The fact that there's a bunch of words here should not deter you. This f of x is the amount that's left in the air. If that's bigger than 100, it's not safe. And all you have to do is plug in the x. So we have f of x equals 1,000. See, you could panic on this problem and run away, but it's easy. And the x over 30 is just 80 over 30. And that's more than one number in the numerator, so we would bracket that. And if you wanted to put that in your calculator, you just put in 1,000 times 0.5 to the power. And you could reduce that 80 over 30 to 8/3. There's no reason to call it 80 over 30. And you just enter in that calculator. So I'm putting into my calculator 1,000, open, 0.5, close to the power, open, 8 over 3, close, and I get the amount. I didn't give all the decimals because they're not important. It's about 157. That is over 100 kilograms, so not safe. A problem that looked really scary was really very easy to do, and that completes the podcast.